and I'm here to teach you about dimensional analysis. Dimensional analysis is what we use to convert between different units. And we use these different units in chemistry to measure different things because we're a very quantitative science, meaning we deal a lot with numbers. To understand how to do dimensional analysis, we have to first understand conversion factors. An example of a conversion factor which allows us to convert between units would be that $1 is equal to 100 cents. So if I wanted to perform a problem where I was given the information that I had $2.50 and I wanted to solve for how many cents that actually was, I would actually have to use that conversion factor above. The way dimensional analysis works is that we use this conversion factor to change the dollars into cents. We're not changing the quantity of the money we're dealing with, we're changing the units describing that quantity. So to start off a dimensional analysis problem that's a single step, you start by writing out the given information, and then you write times, fraction, equals, and then you write out the units that you're going to. The units that we're going to in this problem are cents. Now, I have this conversion factor, that's why I've written one fraction. This conversion factor up above is used to place units on top and on bottom to change my dollars into cents. The unit on top is always going to be the unit I'm going to in this conversion. The unit on bottom is always going to be the unit that I started with. So that's going to be dollars. And I'm going to write a little note as a reminder about that information. So again, on bottom is what you started with, and on top is what you're going to. Now, where do the numbers come from? The numbers in this problem come from the actual conversion factor. The conversion factor says that it's $1 for every 100 cents. So I look for where dollars is on my fraction, and then I put the number 1 next to dollars, just like it is in the conversion factor. And then I'm going to put 100 next to the cents. Now, when I perform this calculation, what I'm going to do is take the 2.5, multiply it by the numerator, hit enter in my calculator, then divide by the 1. Well, since I know dividing by 1 doesn't change the number, I'm not even going to bother doing that. So 2.5 times 100 gives me 250 cents. Make sure that you show the units that are canceling out. See, the important thing to remember is that if I have a unit on top, if I have that same unit on bottom, it cancels itself out. This concept is really important. We use it quite a bit. I'm going to show you an example of that. Say I have a calculation where I have centimeters squared divided by centimeters. Well, we need to remember that centimeters squared is the same as centimeters times centimeters. Now, centimeters times centimeters over centimeters, the centimeters and the centimeters cancel each other out, and I'm left with just centimeters. Units can cancel each other on top if they're on bottom. So if I have a centimeter on top and I have a centimeter on bottom, they can be crossed out. And this is a very important concept dealing with dimensional analysis. Now I'd like to go through an example where you're dealing with two conversion factors to convert units. Say I'm given a problem where I know I have a large volume. Say I'm dealing with 4.5 kiloliters, and I want to convert those kiloliters into milliliters. Well, if I want to do that, I only know two conversion factors off the top of my head. Those two conversion factors I'm going to put in this box below. I know that for every kiloliter, I have 1,000 liters. And I also know that for every liter, I have 1,000 milliliters. Using these two conversion factors, I can convert my kiloliters to milliliters using two steps to solve this problem. Whenever I do a two-step calculation in dimensional analysis, I put two fractions instead of just one. And I go to my end units, which are going to be in milliliters. Now, the first conversion is going to be getting rid of kiloliters. So I'm going to put kiloliters on bottom. Now, the only conversion factor that I know that's going to be able to solve this fraction or work on this fraction right here is going to be this top one right here. So I know that I'm going to have to go to liters. The next fraction, I know I'm going to have to get rid of these liters and change them into milliliters. So what I'm going to goes on top. What I'm coming from, which is the liters, goes down on bottom. Now we fill in the units that we need. So we've got the units. Now we need numbers, 1 and 1,000. The 1 is next to kiloliter, so I'm going to put it down next to kiloliter. The thousandths next to liters, so I'm going to put it up top. Looking on this fraction over here, I have 1,000 next to milliliters, so I'm going to put that over here. And I have 1 next to liter, so I'm going to put that down below. Making sure that I set it up correctly, I should see all the units cancel out except for milliliters, so that my kiloliters is completely converted to milliliters. Let's see if that worked. So I have KL on top and I have KL on bottom, one of each, so I can cancel those out. I have liters on top and I have liters on bottom, so I can cancel those out. That means that I'm only left with this unit, which are milliliters. So that would be 4.5 times 1,000 times 1,000, and that would give me my answer in milliliters.